Okay, in this next section, Unit 5, Lesson 15, problem set 15.2, we're going to answer the following questions for each of the two solids shown here. So what we're trying to do here is we're trying to break down, making it a little bit more difficult for you to find the needed information to find volumes. So here we go with part A for figure A. Which measurement do you need to calculate this volume? Well, this is a cone, so I know that we need the radius. Okay, for part B, how can you find the value of the missing measurement? Well, for this one, I notice that I have a right triangle here, and I'm missing one side length of a right triangle. So I know that I can use the Pythagorean theorem. Okay, and my Pythagorean theorem would look like this. R squared plus 7 squared will be equal to 8 squared. Okay, so that's the information. That's how I could find it. Part C, what volume formula applies? Well, it's a cone, so the volume is equal to the area of the base times the height and divided by 3. And then finally, part D, we're going to calculate the volume of this solid. So remember, the first thing we need to do is we need to find the radius here. So I know that if I take this equation from part B, I can solve it for r squared by subtracting 7 squared from both sides. So r squared is going to be equal to 8 squared minus 7 squared. So then in my calculator, I'm going to do 8 squared minus 7 squared, and I get 15. Okay, so I know that my radius squared is 15. That means my radius must be the square root of 15. Now, we're going to pause here for a second because I want you to notice something. This r squared value is 15. If you think about using the radius in this volume formula, I know the area of the base, since it's a circle, is pi r squared. So realistically, I want to use this 15 as is, right? Because that's r squared. So I know that the area of the base here is r squared times pi, or pi r squared, same thing, times the height. Well, my height is 7. Then I'm going to divide by 3. Remembering what we did last video, we can cancel this factor of 3 with a factor of 3 here and change this 15 pi into a 5 pi. And 5 pi times 7 is 35 pi. So the volume of this cone is 35 pi. And if I want to round it to the nearest tenth, if necessary, so if we round this, I believe, yeah, it says up here, round to the nearest tenth if necessary. In order to round this, I'm just going to type in 15 pi into my calculator, and I get, 35 pi, not 15 pi. 35 pi. And I get 109.95. If I round to the nearest tenth, that 0.9 is going to go to a 0.10, which means this will round to 110.0 cubic units. So there's the volume of that first figure. If we take a look here at the second figure, we're going to answer the same set of questions. For part A, we want to know which measurement do we need? Well, we need h, the height of this figure. This is an oblique rectangular prism. Part B, how can I find that? So if I look at this figure more closely, I notice that I have a right triangle here. I can find the height by using trig. I know that the tangent of that 65-degree angle is equal to the opposite, or h, over 3. So then my height is whatever 3 times the tangent of 65 is, because I multiply both sides by that denominator. So that's how I would find part B here, how I would find the height. Part C, what volume formula applies? Well, for a rectangular prism, the volume is the area of the base times the height. And then for part D, we can find our volume by just plugging in. The area of my base is this rectangle on the bottom, which is 7.5 times 4.5. And then my height is this 3 tangent 65. So I'll just plug that in. 3 tangent 65. Now I can calculate my volume with my calculator. I'll pull that up, and I got 7.5 times 3.5 times 3 tangent of a 65-degree angle. Enter, and I get 168.9 rounded to the nearest tenth. And that is meters cubed. Okay, so there we go. We were able to find the missing information that we need in order to solve these. So I want you to realize that it's not always going to be given to you with exact information. Sometimes you're going to have to do things that we've already done to get the measurements you need.